I said shot, Jeremiah. Not shop, I said shot. You demon. This is hard, man. Let's see what he does. What? Did I wind it the wrong way? Film it. I know, but that's not the front, so it has to go right the right way.
We decided to make the car as narrow as possible because we figured that having a car that was more narrow would make it more aerodynamic, as there would be less width for air resistance to hit straight on. As you can see, we use small popsicle sticks to hold the base of the car together. We hope this would provide greater stability for the car. The purpose of the black thing is to hold the skewers in place, as the skewers will be acting as our axes of rotation, so we need them to be as fixed as possible. That is why we will be using 2 sets of black hole things, because I'm afraid it will be too wobbly with just one. We decided to add a hood to our car to make it more aerodynamic because we figured that having the air hit it at an angle rather than straight on would reduce the air resistance, as it does with modern cars. For the wheels, we decided on medium-sized lids. We did not want them to be too large, as that would increase the rotational inertia and therefore make it harder for them to move. The edges of the lids provided rough surfaces necessary to start rolling the car while not being too rough that friction would impede its motion. The skewers were inserted into the corresponding holes on the other side so that they would not be slanted, or else the car would turn as it moved. The wheels were attached as straight as possible so as to prevent this same issue. Caroline clipped the skewers short to preserve the narrow aerodynamic build of our car. Since they were all drilled in the center, the wheels were balanced on both ends and wobbliness was limited. The holes were made so that they were just small enough to keep the lids attached to the skewer, as they would be our axis of rotation. Bottle caps were attached to the outside of the lids to hold them in place and prevent wobbliness. Additionally, glue was placed on the skewer around the lids. We had now built the car. All that was left was to add the mousetrap. The string served to hold a stick on the mousetrap down so that it could be released and provide the force necessary to overcome static friction and inertia and send the car into motion. A plastic tie was used to hold the string in place and prevent it from sliding off. The added mass of our decorations was just what we needed to stabilize the car and keep it relatively straight. Lauren and Kiana's car had a very good glide since the only friction on their wheels were 2 rubber bands in the front. This allowed the car to travel far as there was less friction acting against its motion. Meanwhile, Mike and Ant, in an attempt to provide this friction on smooth CD wheels, covered them with balloons. Though it did provide friction necessary to start rolling, the CDs themselves were too wobbly and caused their car to veer drastically to the left. Josephine and Julia were hindered by their decorations. They did not account for the friction between their cotton clouds and string, which caused the car to slowly speed up in the beginning and travel less distance than it could have. This data was collected by timing how long it took for our car to travel 7 meters with 1 meter intervals. The only materials used were a stopwatch and meter stick. For average velocity, acceleration, and final velocity, only kinematic equations were used. Since final velocity and acceleration were for when the car had traveled 5 meters, only the time up to 5 meters was used rather than the full time that we tracked. Since impulse is defined as a change in momentum, we used m delta v as our equation to calculate impulse, since we did not know the average force exerted on the car over the 6.2 second interval. Naturally, in our calculations, we assumed that our car had traveled straight, but that is obviously not the case. As a result, our car had technically traveled more than 5 meters within what we measured and calculated, since it had taken a curvy route to get to each interval. Furthermore, we assumed that the friction of the floor was constant throughout, but that is most likely not true since some parts will be smoother than others due to a variety of factors, such as uneven waxing. This assumption did not impact the data much, though, as shown by the relatively smooth DT and VT graphs. If I had to redo this project again, I would try and obtain wheels like Lauren and Kiana had, since they did not wobble and seemed very easy to attach to an axis of rotation.